This is perfection. CPU is doing its uniform thing, render is happening, it's getting put on the display perfectly. All the steps, this is 10 milliseconds between the frame, you'll see animation move forward 10 milliseconds. Down here on the flip, it also matches that 10 milliseconds, so everything's great. Now, what can go wrong? A lot of things can go wrong. Here's my animation, look for it, right there. Okay, so what happened? If you kind of come back, you're saying, you know, we're rendering, everything's going great, but then maybe the CPU stuttered. The CPU did a network activity, or maybe it was loading a new texture, or maybe it was, you know, just running out of cache and it had a flop. So it's this gap, this little like hitch that we all perceive as lack of smoothness. And the way we're measuring it today is this thing that we call percentiles, where you're thinking 1%, 5%, 10% percentiles captures that effect. But that's not actually true. So what does capture that effect is animation error. And the way it works is it says, what is the animation step that we know is in that frame? The animation step is, you know, how far are things going to be moving forward? If the velocity is constant and the time step is bigger, it's going to move further. So this is taking a 4x step in that picture. Now, the problem is that this 4x step was caused by a CPU delay. The render pipeline, the rest of this GPU display doesn't know anything about it. So when it gets the first frame, it puts it on the screen, but it stays there because it doesn't get the second frame. The second frame is stalled on the CPU, but eventually when it comes, it does show. But all of this means that things are showing up at the wrong time in the wrong place. So that's what animation error measures. It measures how wrong are we showing things at either the wrong time or the wrong place.